Hello, JsPoland. My name is Amanda Sopkin, and today I'm going to be talking to you about the past and the future of JavaScript. So as a short agenda of where we're headed, I'm going to start out by talking about some of the things that make JavaScript the language we know and love today. And then I'll follow up by talking about some of the things that can make us a little bit crazy when it comes to JavaScript. Then I'm going to go into the history of the language and how it's evolved throughout the years. And I'll end by talking about some of the exciting things that we can look forward to in the future of JavaScript. So JavaScript today is really the powerhouse of the web. It's the only runtime language of the web. And I think it's kind of an interesting thought exercise to consider what it would be like if we didn't have a language like JavaScript, where you can go to any major browser and you're able to interact with the elements on a web page by using one language. If we had to learn a different language for every single browser, that would be incredibly difficult, and it would just be a much less welcoming environment to grow as a programmer and begin to understand the internet. So we have JavaScript to thank for all of that. And JavaScript today is everywhere. There are new frameworks almost every day, it feels like. These are some of the very popular ones. You're probably familiar with both React and React Native, which has made it possible to use JavaScript to do mobile programming. Electron makes it possible to use JavaScript to do desktop application programming. Node.js makes it possible to run a server and do back-end programming that's performant using JavaScript. And Angular and Vue are two popular front-end frameworks. So it's really taken off like wildfire, and there are a ton of new innovations basically all the time, which is pretty exciting. Good time to be a JavaScript developer. And again, as I said with Node, JavaScript is server and client-side capable, which means that you can have companies like where I work, where you do some back-end programming using Node on the back-end with JavaScript, and then you switch over to do some front-end programming, and it's still in JavaScript, which is really nice not to have to switch mental contexts between those two and be able to do full stack programming in one language. JavaScript is by far the most common programming language. It's in use by 67.8% of developers, which is pretty incredible, and partly because it's so prevalent with the web and also with all the different popular up-and-coming frameworks that we talked about. And JavaScript is backwards compatible across 25 years of versions, which is really incredible and helps to explain some of the little quirks in the language that we're going to talk about today. So that brings me to the next section, which is sometimes there are things about JavaScript that cause us to throw our hands up in the air and wonder exactly what's going on here. In 2012, there was a really popular talk about some of the weird parts of JavaScript called WTF.js that went through a lot of the things you might see if you're developing in JavaScript that might make you crazy. So I'm going to talk about some of the popular ones briefly. So the number 1 is equal to true in JavaScript. 0 is equal to the empty list, and these are all using the double equals operator. Null is equal to undefined, but null is also greater than or equal to 0. The type of not a number is number. 0.1 plus 0.2 is not equal to 0.3, but 0.1 plus 0.5 is equal to 0.6, which is a side effect of using floating point arithmetic in JavaScript, which other languages get around by using slightly different formats for numbers. Overflow, if you continuously type a bunch of 9s, eventually JavaScript will throw its hands in the air and flip over to the next number. And math.max is equal to negative infinity. So some of those things contribute to what I think is a well-deserved title. JavaScript is sometimes called the world's most misunderstood programming language, which means that there's a lot of love for JavaScript. It's obviously very popular, but there's also a lot of animosity. So I want to talk a little bit about exactly why that is, why JavaScript still isn't everyone's cup of tea, and maybe 10 or 20 years ago was even fewer people's cup of tea. So this is a comic that I found kind of from the original years of using JavaScript. It says, employees must wash hands after using JavaScript. So it's kind of implying that JavaScript is dirty or will make you sick, which was a more common attitude when the language was first developed. And why is that? Part of the reason is that JavaScript in its initial version was really designed more for scripting than performant web programming. So particularly early on, if you compare the original JavaScript to other popular languages at the time, like PHP, it was much less structured, and also you couldn't run it in very many performant contexts. So that contributes to kind of this sense, it used to be said that it's not a real programming language. I think another thing that contributes to some of the animosity around JavaScript is that there's sort of a history of putting the cart before the horse. So what I mean by that is it's extremely popular, and developers have this tendency of looking at all problems like nails and looking at JavaScript as a hammer that can be used to solve those problems. So you can kind of see that with all the frameworks that we talked about before. There's a lot of examples of where people will get really excited about using JavaScript for a specific context or purpose and then realize that it's not quite designed for that or there yet and start asking for new features. And then eventually we'll get a new framework or we'll get more features that we want, but not until after people really need them. And then I think the third big reason why JavaScript receives a lot of animosity or jokes is because of all those quirks that I showed you before, a lot of which are side effects of having to maintain backwards compliance for so many different versions for so long in the past. So JavaScript development today is quite different. There are a lot of workarounds if you want stricter enforcement for things like types. There are very performant engines that can run JavaScript, which we'll get into later, but that was not always the case. And with ECMAScript 6 in 2016, we got a lot of new features that people really wanted that made programming in JavaScript what it is today, which is a lot easier and more pleasant than it was originally. So now I want to talk about the history of JavaScript. In 1993, Mosaic, which is the first popular web browser, was released by Netscape. And basically from the get-go, they started looking for a language that could be used to do implement dynamic behavior on the web. So virtually all websites could be used in a static context, but they wanted a way to implement dynamic behavior after the web page was loaded. So they started looking for a language that would make that possible. And 2 years later, JavaScript was created. And it's pretty incredible. It was created by Brandon Eich, and he developed it in just 10 days, which is pretty remarkable. And the name JavaScript, you may know this, comes from Netscape's support for Java applets. And it was a little bit of marketing because they said, oh, Java is a really popular language. If we call it JavaScript, people will like that. And on the one hand, maybe that worked because JavaScript is extremely popular today. But on the other hand, people kind of accept that it's just a weird language it's a weird name for a language that has nothing to do with Java. So a quick note on how JavaScript is run. The JavaScript runtime environment is totally independent of the engine itself. So the engine for JavaScript is what parses the code and converts it to a series of runnable commands. So that can be a browser engine, like for example, V8 for Chrome, but it can also be something like Node.js. The runtime environment for JavaScript is separate. It's the interface to the outside world, which is the same across browsers, which is the reason that I can go to any browser and run some JavaScript and be able to see the same results, which is very convenient. So in 1995, Microsoft produced Internet Explorer with its own flavor of JavaScript called JsPoland. And for the next probably few years or so, Microsoft and Netscape were battling over standards. In 1996, we get the creation of what's called ECMA, which is the European Computer Manufacturers Association. And they decided to come in and lay down the law and set up some standards for the World Wide Web. So ECMA is run by a council, which gets its authority from a general assembly of members. So the way that it works is that member companies that have a vested interest in the continued development of JavaScript So companies like Microsoft and Google, for example, will pay a fee to be on the council and have voting privileges, depending on which level they're at. And then they will help design the technical standards for the continued development of what's called ECMAScript. So the ECMA Council does create other technical standards, like, for example, formats like XML, but they're probably most famous for continuing to develop ECMAScript, which is all basically used interchangeably with JavaScript. So another big development for JavaScript, in 2005, we get the development of Ajax, which is really more so the popularization of a particular technique. It's called Ajax because it's asynchronous JavaScript development with XML. So it's a way of applying tools that were already available on the web to be able to load data in the background without a full page refresh, which is huge for modern web development. And having that technique allowed for the creation of tools like jQuery and Prototype, which are a huge piece of the history of JavaScript. In 2007, there was something introduced called Atwood's Law in a popular programming blog by Jeff Atwood. Atwood's Law is that any application that can be written in JavaScript will eventually be written in JavaScript. And I think this has really been borne out by the history of the language. You can see with, for example, frameworks like Electron that make it possible to develop desktop applications in JavaScript. And this kind of comes back to the tendency of developers to create JavaScript frameworks for basically any purpose, which has led to all of the frameworks that we have today and a lot of innovation, which is awesome. In 2015, ECMAScript 6 was released, which had a ton of features that people were really excited about. I wanted to highlight some of them. You could use let and const to declare variables rather than just var. Arrow functions came out in ECMAScript 6. Promises were introduced, which is huge for asynchronous development. Modules were created so that you could repackage code for later use. There were workarounds for doing that in the past, but this was still a huge breakthrough for JavaScript programmers. And a lot of syntactic things that people really wanted, like destructuring and more string functions, etc. So this was huge. People were really excited about it. Still are. And a quick note, ECMAScript is backwards compatible across all versions. It is the only runtime language of the web for 25 years back, and basically carries all modern web browsers on its back for that reason. It's absolutely huge for the way that we interact with the web. And if you think about what it would take from a technical perspective to maintain backwards compatibility across that many years, it probably helps you understand JavaScript a little more and all of its quirks, because what it's doing is really technically very impressive. And when it comes to backwards compatibility, kind of a workaround that they created was to allow for stricter enforcement of rules if you want it. So you can run this code in JavaScript and you will not get an error. But if you're in strict mode, it will give you an error. So running JavaScript in strict mode allows programmers to receive a slightly stricter enforcement rather than just silently making mistakes. So one of the original big problems with JavaScript is that you could write things like this and not know that there was a problem, which makes debugging very difficult until there is a big problem. So strict mode is kind of a way to get around that. It's sort of like a chameleon. It's allowing you to maintain backwards compatibility, but also have this way to run things with stricter enforcement. So now I want to talk about some of the popular offshoots of JavaScript. So I'm just going to talk about 4 of them today. In 2010, we get Angular. In 2011, we get React, which was open sourced in 2013. 2011 also brought us Ember.js, and in 2014, we got Vue.js. So I want to talk a little bit about those. Angular was developed with the purpose of improving single-page applications, and it's extremely prevalent on the internet. It's in use by almost 500,000 websites, and if you search Stack Overflow for questions on Angular.js, there are over 230,000 that have been answered. Which I think is an interesting benchmark of its popularity. So huge piece of the internet as we know it today. React is even more popular. It was originally developed to build composable user interfaces. And it's in use on an estimated over 1 million websites. If you look for questions on React on Stack Overflow, there's over 250,000 different questions, and React is huge. Ember.js was initially created to develop ambitious web applications. So it's in use by over 90,000 websites. And there are some really big names there of companies that are using Ember.js in order to create really performant web experiences. For example, Netflix and LinkedIn in Square. And Vue.js was developed in order to be lightweight, performant, and flexible. And it's kind of loosely inspired by Angular. It's in use by over 100,000 websites, including part of Facebook. I think the Facebook news feed uses Vue. Alibaba, which is the world's largest e-commerce site, and Adobe. So some really impressive names there as well. So the JavaScript ecosystem is kind of unlike anything else. There are 24 major frameworks and 83 major libraries. And if you search for developer jobs, at least over a third of them list JavaScript as a strict requirement, which I think says a lot about how important it is in programming in general today. It's kind of hard to imagine a world without it. So it's a very lively ecosystem with constant development of new frameworks and applications. So when we look to the future of JavaScript, some of the things that will uniquely prepare JavaScript for the future are that ecosystem that we talked about before, which is a ton of different developers that are eager to find new contexts to use JavaScript. It has a track record on tons of different platforms. So if you were to say, oh, I think we can use JavaScript for this thing, people are not going to tell you you're crazy because it's been used for so many different things already. And just its prevalence as a language. Like I said, 67.8% of programmers use JavaScript, and it's basically in the water of web programming. So that prevalence also will help prepare it for the future. So what is in the future of JavaScript? I just want to point out a few things that could be in the near to immediate or far off future. A lot of people ask for better object-oriented programming support, and there is a proposal to introduce private variables that would look like this. So you use a £sign to declare private variables. Support for true reactivity. So reactivity allows you to run code that looks like this, where you're defining first number after second number, but you're using the first number in the second number, which is not possible in a lot of languages today. Basically, the way it works is that when compiling, it creates a dependency tree of all these different variables so that code like this can be run, which is pretty exciting to think about. And I think JavaScript will be applied to more contexts with AI and machine learning. An example of that is the development of TensorFlow.js. So those are some of the exciting things that we are likely or may see in the future that you can look forward to. And a quote that I think is good to point out here from Nick Morgan is, "JavaScript is a leather sheath with a really, really sharp knife inside. That knife can cut anything, and with it, you can do anything. You can kill a bear, you can catch fish, you can whittle a piece of wood into a pony. It's even a toothpick." So this is describing the power of JavaScript to be applied in almost any context. And we've seen it do that successfully in almost an unlimited number of examples. So it's really exciting to think about all the things we probably can't even imagine today where JavaScript will be used in the future. So the future for JavaScript is bright. Hopefully this talk helped you understand why it's misunderstood and all of the good things it has to offer. I wrote a love poem for JavaScript because I was so inspired while doing this talk and researching all of the cool things about JavaScript. Roses are red, the empty list is true. Oh dear JavaScript, the web is nothing without you. So hope all of you were inspired by everything JavaScript has brought us today. Feel free to follow me on Twitter if you have questions. Love to talk about this kind of thing, and I hope you enjoy the rest of your conference.